Hi, Kai Jacobson here. This is the second part on ORP. If you haven't watched the first part, watch that first. It's about how ORP, which is oxygen reduction potential, actually works as an antioxidant and as a fighting free radical damage in the body. It's amazing how those free electrons actually really work as decoys and protect your body in an incredible way as an antioxidant. This part specifically on what's called redox. Redox is the same thing as ORP, but it has a function that I like to talk about in a different way and how that actually works in your body. In physics, we talk about things describing the physical world in vectors, and what vectors mean is that there's a multiple of factors that have a bearing on reality. In the physical plane and in Newtonian science, we talk about vectors about a very common thing like velocity, how fast something's moving, and the mass that it is, how much does it weigh. And those two vectors, which are two different elements in reality, have a very big bearing on what happens. If you take that and put a graph, if you put along the bottom of a graph the velocity, how fast something's moving, and going up on the side of a piece of paper to create a two-dimensional picture, which would be the mass, how much does the object weigh, you can see that both those things have a bearing on what happens in reality. A great example would be something moving along at the velocity of 70 miles an hour and having a mass of, let's say, a leaf. If it was moving in the wind, like there was a big hurricane and a leaf hit you at 70 miles an hour, that leaf, because it weighs maybe a gram or even less than a gram, or it's very light, it might scratch your face a little bit, but it's not going to do any big damage. Whereas if a car hit you at 70 miles an hour, or a truck, a car being 2 tons at 70 miles an hour, that's a significant event. Well, pH and redox can be put on that same graph. You can put the pH, which is a 1 to 14 measurement. The pH, what reading is it? Is the water at 7.2? Is your body at 7.2, 7.8? Those are all different numbers you can put, which you could almost make as an analogy how fast something's moving, the velocity. Going up the side of the paper would be the redox, and the redox would be an analogy could be made to the mass. I like to say it's the cranking power, like in a battery. It's like the amps and the volts would be at the bottom. So the redox is a very important factor. It's a vector that has a lot of importance. Just the alkalinity of the water is only part of the picture. You have to look at the redox too, which is how much cranking power or staying power does the alkalinity have, like the depth or the mass of its ability to really have staying power, especially in the body. How long can the alkalinity really hold on a cellular level? What does the battery, your body's reserves have? That's another way of saying it. Of course, now there's even a third vector that happens. It's called resistivity, which makes this graph now three-dimensional, like a cube. And when you really look at a body, you want to go, if you really want to do a very good test for yourself, you can go get what's called a BTA, Biological Train Assessment. And a BTA is a test where they take your urine, your blood, and your saliva. They take all three fluids and they do all three tests on it. You can test the pH of your blood, the redox, and the resistivity of it, and you can do that on all three fluids, on your urine and on your saliva. And then they take those 9 measurements and run it through a computer software program that's been designed specially to compute exactly where your biological terrain is, what the real picture of your alkalinity is. So you can't just take a pH strip and test your saliva or your urine. You can get a little indication, but you really need those 9 measurements and interface all of them to get a really deep, in-depth picture of where your true biology is. Because the blood is always being buffered. It's always like kind of like a thermostat, like a room would be maintained at 70 degrees temperature, and it's pulling heat, from other places to heat it up, or you could put an air conditioner on to cool it down. Well, it's the same in your body. Your blood's always being kept at 7.34 pH, and it's pulling alkalinity out of your reserves, which can be seen as your redox in a way, if you think of it in terms of a battery. So finding what your redox is really important on your biological level. Now, when we measure the water, we're checking out the redox of the water is just the electrical charge in it, which is the ORP, and that is called redox too, but that can be done on all the fluids in your body and get a deeper picture of what's really true and going on in the chemistry of your body. So it's a very important thing. And resistivity is another measurement that's quite important too, which is how well does a fluid conduct electricity. If it's very resistive, it has a high resistivity, which means it doesn't conduct electricity very well. Like distilled water has no minerals in it, and it's a fairly good, it's kind of a good insulator. It doesn't conduct electricity well. When you have a lot of minerals in the fluid, it conducts electricity very well, and that's called low resistivity. And so you look at the resistivity factor in the fluids, and you get a really good idea of where the minerals are moving. Like, are you pissing your minerals out of your body? Are they getting leached out of your body? If they are, that means you're getting very acidic. And when you get very acidic, you start finding a lot more concentration of minerals in the urine, which means the resistivity of the urine's going down because there's minerals in it. And you really want to have the resistivity in your urine being up, meaning that you're retaining the minerals. So that's another reason why you really want to stay alkaline in your body, is to retain all the good minerals that you're getting from the foods that you're eating and from the water that you're drinking. So that gives you a little idea of resistivity and of redox, which is another part of the equation. These are other vectors that are very important in looking at your whole chemistry. So just reading the pH is only a piece of that puzzle. And what we're wanting to do with this information is really talk to you about how important working with the redox and the ORP is and why that's such an important part of what this unit, the Delphi and the Athena, do for your body by helping raise the redox levels in your body and helping your body retain the minerals by helping you becoming more alkaline at a very deep cellular level, not just a surface level. Okay, thanks very much.